A star in the sky is about to flare dramatically. If you look up at the constellation Coronae Borealis, right now you won't see much below the C-shaped curve of the constellation. But I can promise you that there's a star right here. It's just so dim that you can't see it with the naked eye. But that is about to change. Astronomers have been waiting for months, years even, for the star T Coronae Borealis to have one of its typical outbursts. It is what we call a recurrent nova, which is actually a star system consisting of a dense small star, such as a white dwarf, that is accreting material from a larger nearby star. The material builds up on the surface of the dense star until eventually the pressure is so high that an explosion is detonated. T Coronae Borealis is the closest recurrent nova that we know of, and we've been watching it explode for centuries. It has an outburst roughly every 80 years, which has earned it the nickname Blaze Star. And it's about to explode again, in such a powerful fashion that within just a matter of hours, it will become as bright as Polaris, the North Star. And then it will dim again. Even though T Coronae Borealis is a recurrent nova, the exact outburst time is unpredictable, which makes it a real challenge to observe, especially with large telescopes. The thing is, we want to catch it before it dims again, so that we can learn something about the physics that triggers the explosion. We have to be fast. Unfortunately, you don't just suddenly get to decide that you want to use an ESO telescope. You need to have a good reason and schedule well in advance. Observations for ESO's Very Large Telescope, or ALMA for example, are allocated many months in advance. Scientists submit observing proposals, where they explain what object or what part of the sky they want to observe, and in what way. And of course, they also need to explain what they hope to learn from the observations. The proposals are then evaluated by a team of science experts, and only the ones that are approved actually get an observing slot. This slot doesn't just have to meet the scientific requirements of the observations proposed, but also fit neatly into the telescope schedule. And competition is really tight. Luckily, most celestial objects remain unchanged for millions, if not billions of years. So whether we observe them a few months earlier or later really doesn't matter. But that's not the case for all of the exotic objects lurking out there. Often we get no warning at all that something is about to go off with a bang. This is the case, for example, for gamma ray bursts. They also fade very quickly, which means that we have to be very quick if we want to catch them. For astronomical emergencies such as this, ESO telescopes have a cool feature called rapid response mode. It's used only a couple of times a year, but when it's triggered, an alarm goes off in the telescope control room, and the ongoing observations are aborted. The telescopes are repositioned as quickly as possible to catch the new unexpected phenomenon. For outbursts like the one in T Coronae Borealis, there's more time to react, as here things happen on a timescale of days to weeks, rather than minutes to hours. Also, astronomers spotted signs of the imminent explosion about a year in advance, meaning they had plenty of time to prepare observing proposals. The accepted proposals were then put on hold and will only be triggered once the outburst has happened. These kind of bright outbursts are often picked up by amateur astronomers first, because they have unlimited access to their telescopes. They then use software tools to notify professional astronomers that something's going on. ESO can then point their telescopes at the event the same night or within a few nights, depending on how fast it is expected to be over. ALMA, for example, is ready to start observing T Coronae Borealis when the time comes, as are other telescopes. With the data gathered, astronomers hope to learn more about the life cycle of binary stars and the stellar explosions that fuel them. We've never been able to observe a T Coronae Borealis explosion with modern telescopes across multiple wavelength ranges, so I'm super excited to see what we'll find. In 1946, the last time T Coronae Borealis had an outburst, scientists didn't have the instruments to properly study novae. Today they can, thanks to telescopes like ALMA. From the data we have, we know that the explosion is overdue, so it could happen any day now. Keep watching this space for breaking news of the Blaze Star.